The next one that I have is somewhat redundant, but still it's important to realize that x equals 0 is the YZ plane. And likewise, y equals 0 and z equals 0. So y equals 0 is the xz plane. Actually, because we want to go in order, I'm going to write it as the zx plane, because we go x, y, z, x, y, z, x, y, z, keeping the right-hand rule. So it will be the zx plane. And z equals 0 is the xy plane. All right? So this is something that we know intuitively. There is something called Cartesian product that we need to introduce. And it's a matter of just notation. And what is the Cartesian product? Well, we're going to say that in R2, R, of course, stands for the set of all real numbers. R2, like so, means that we are dealing with two-dimensional function or universe that is two-dimensional. In R2, we're going to say that R times R, this kind of product, is the set of all point x, y, such that x and y are real numbers. Okay, so I use the set generator notation, and this is how you read it. In R3, likewise, we're going to have a 3 by a Cartesian triple product. So we're going to write it like so. And this will be the set of all points x, y, z, such that x, y, z are real numbers. Okay. In more practical terms, the point on a plane xy, on the xy plane, so a point xy in R2 is an ordered pair. Okay. If we say we have a point 7, 2, it's ordered because 7 is the x value and 2 is the y value. So we are looking at ordered pair. But a point x, y, z in R3, likewise, it will be an ordered triple. So we do have this term, and here I forgot the word and. So, right. So xy is an ordered pair. XYZ is an ordered triple. And finally, the last note. Again, it's almost trivial. We're going to say that in 2D or in R2. Actually, let's do it in R2. I prefer that. In R2, like so, an equation in xy represent a what? What will it represent? An equation in xy in R2 represent a curve, exactly. I was expected to hear somebody say a line, but no, a curve. In R3, an equation in xyz represent, what will it represent, guys? A surface, right. A plane is a particular case, is a special case, is a surface that has one fixed value. Either x is fixed, or y is fixed, or z is fixed. And if x is fixed, then y, z will be variable, and so on. But a surface in general. Now, we dealt with surface in calculus 2, but that was a special case where we dealt with surface of solid of revolutions. So in this course, we'll deal with other kind of surfaces. All right. So here's the first example, or the second example, actually. So